broad question, excuse me, I'm going to have to sip a lot of water today. Anyway, another broad question is, how many of you have some experience with GIS in the past? It sounded like it was a little bit and probably a few years ago, right? Okay, well that's fine.
Does ArcView count?
Yeah. So the agenda for today, I'm just going to give a quick presentation at the beginning, talk about what a GIS is, and sort of how it looks at the world and what it's designed to do. But mostly we're going to be doing hands-on activities, step-by-step tutorials. So doing things like previewing GIS data, seeing what it consists of. We're going to then move into creating maps. You know, this is one of the fundamental uses of a GIS is to make maps out of spatial data. We'll talk about how you symbolize the data and visualize it to, say, communicate the message effectively. I'll show you how to export a map using the software. So by the end of today, you'll be able to create a simple map and export it to include in a report or a website or something like that. And then at the very end, we'll talk about where you can go from here and other resources that are available to you at Clemson. So just to again point out who CCGT is, the Clemson Center for Geospatial Technologies. We're a support group or support service for all of you, right? So we do things like give customized workshops like the one you're attending. We can also support classes. We can come in and teach up to 2 lectures to your students to do some specialized material. We do one-on-one consultations. So if you're working on a project and need specific help or technical support, we're there for you. We manage the licenses for ArcGIS software that you're going to be using today. We can help you install that software on your own computer. And then we also have a couple of facilities, our training room here, and if you haven't been next door already, to our collaborative space. That one is open whenever the library is open. It has the same setup for the computers, dual screens, big hard drives on the computers for storing large data sets. We also have an augmented reality sandbox. That's a lot of fun. Come on in. It's a lot of fun to play with. If you're stressed out, studying for an exam, need to blow off some steam, it's fun. And maybe during the break, we can all go over and check it out. All right. So, just to give you some examples of a GIS, I asked a minute ago how many of you were already users of a geographic information system or a GIS. And that's sort of a trick question. You don't think you're using it when you go on your phone, get out a mapping app. Yeah, come on in, log into a computer. That's fine. So yeah, you aren't thinking I'm performing GIS tasks when you do it. Even when you go into Google, say, I'm hungry, where's a pizza place near me? I want some pizza. Search in 5-mile radius. It's taking your location, so some sort of geographic information, and then it's looking through a database of information to find results that meet those criteria. So it takes your location, the database combined in a Google search. It's also simply using a GIS. It might be a GPS unit in your car. These are sort of old screenshots, MapQuest directions that you would actually print out and use. Things like Google Earth, these are all forms of a GIS. So you already probably used it in some way without knowing it. But to be precise in defining what it is, a geographic information system is some sort of software or computer tool that links geographic information, right? So some position with respect to the Earth with descriptive information, or what I'll refer to as attributes. So it combines where things are with what they are. And in the old days, and I'm being kind of tongue-in-cheek here, maybe 20 years ago when things were still mostly on paper, a paper map would be where you would go to get geographic information. But a paper map can really only hold all the information that's printed on it, unless you have some big appendix along with it that contains extra information. So you could look at things like roads, buildings, waterways, all these different types of information, but a paper map's limited, especially when it comes to analysis. So if you're going to look at, say, where crimes have occurred, and then try to determine the best way to get to those locations from, say, a police station, you'd have to do this all on paper. And again, all the information you have is just what's actually here on the page. But with digital maps, with the GIS, you can go a lot deeper. You can store much more information. So not only where are these crimes occurring, you can do network analysis, for instance, to figure out the best ways of responding to these crimes. You now have all this other information. So what type of crime was it? It was an assault with a deadly weapon. What time did it occur? What was the address? Who responded? How long did it take? So on and so forth. So, does that make sense? So a GIS combines the mapping with also a database. So, or a spreadsheet you can also think of information. Here's another quote that describes a GIS. It's the system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying data. The most important part is that these data are spatially referenced to the Earth, once again. So the way a GIS looks at the world is that it breaks up the real world, which is messy and complicated, into thematic layers. Right, so it combines data based on some type of theme. And because these different layers are referenced to the Earth, you can stack them one on top of another and begin to look at relationships between those data sets in a spatial sense. So things like land use, what type of land is it? Is it agricultural? Is it industrial? Is it residential? Types of streets, so how wide are they? How many lanes, which way do they go? You might have districts. These could be things like voting districts, census tracts, land parcels, who is actually the owner of these land, the land, excuse me. You can also look at things below the surface of the Earth, so geology or hydrogeology, so what type of rocks and soils are present, what's the groundwater doing, what are surface water features doing, right? So does this fundamental aspect make sense? We split the world up into these layers based on some theme. And so again, because these layers have a fixed position, their position is known with respect to the Earth, we can then look through our database of information to analyze things spatially or look at relationships. So a simple example would be, let's say we have water wells that are supplying water to homes and businesses, and somebody's monitoring these wells, testing for contaminant X, whatever that may be, and they start finding levels of this contaminant that are much higher than is safe. So now you can go into your database, find out who's actually being served by these wells, who's nearby, what is their address, their phone number, their email address, so I can contact them and let them know. So any questions at this point? All right. So when you talk about GIS data, again, these are thematic layers, but there's really two categories of representing the world, or these data types. One of them is called vector, and one is called raster. And if you're familiar with graphics at all, you probably already understand what that means. But the vector model uses discrete coordinates, right? So they're not defined everywhere. It takes, say, one coordinate to define a point, or a bunch of individual coordinates, say a collection of points. They might be points that are linked together in a line, or they may bound some area and form a polygon. Right, so vector data are discrete, so they're not defined everywhere.